Respected Chairperson, thou has left. Eminent speakers on the dais, ladies and gentlemen, very good afternoon. Namaste to all. I know how much you know about Ion Exchange. I represent a company called Ion Exchange India Limited. Now, this is India's first water treatment company, started in 1964. And most of the technologies in India, whether water or wastewater, recycling, everything, or 90% of the technologies to an extent, I can say, to India is by an exchange, So we are not only technology providers, we are EPC contractors also. So since we are technology providers, we are just like water doctors. We know all engineering, we all know technical schemes and how to purify the water. So today, I'm going to talk, I'll take 2 minutes maximum, talk about that what we do actually. We do a lot of engineering business for water, wastewater treatments, chemicals. We've got more than 1 lakh installations now throughout India and globally also. We got 500 installations in all large PSUs or power plants or steel plants or refineries, fertilizers, petrochemicals, all nuclear power stations, We put up all these mega giant watering plants, DM plants, reverse osmosis plants, recycling, ATP, everything, So we have got a lot of, this is something, it's a British company which started in 1964. And since then, we have almost completed about 62 years now of our existence in the So we've got about 8 manufacturing plants across different states of the India and strong R&D because we are a technology company. So definitely R&D is something our strong forte of expertise. When we launch any technology to the country, this is a center which actually works hard to give us the best possible solutions, So the topic is, of course, it's a very important topic, and I have divided the topic into 3 parts. One is I'm going to talk about the technologies because a lot of things have been mentioned about the water scarcities, challenges which are imposed on it. We give solutions, We provide engineering plants. We provide to urban cities as well as to the industries also. So how you can mitigate the challenges, how you can provide the best possible engineering solutions. So within the framework, what best you can do, it's something is utmost importance for us. So I'm going to talk about water treatment first, right? My second topic will be on ETP recycling, wastewater recycling, right? Actually, it's just mentioned about the grey water or sewage water recycling. So I'm going to talk about effluent recycling. Of course, I'm going to touch a bit on sewage recycling also for industrial applications. And last but not least is something, a very important thing is artificial intelligence, which we are doing in now, in water management of our plants, So first I'll start with the technologies. I hope you know that there are only 2 conventional sources, surface water and groundwater. By the way, I don't know whether you know or not, 50% of the groundwater, more than 50% of the groundwater on the earth is used alone by India. So rest all the countries are using 50%. India alone is using more than 50%, So this is something, a great misuse of the water, which Indians are doing it because of the water scarcities, or we call it as a mismanagement of the water, And of course, surface can be ponds, rivers, lakes, whatever it is there. I'm going to focus on non-conventional. Now, this is something, surface water we believe, or groundwater we believe is only for drinking application. Let's industry and other applications should not touch this water. So what industries are going to do it? So there are 3 sources, sewage, tertiary treatments. You need to depend on the sewage, municipal sewage, to use it for the industrial applications, because sometimes all these industries are water guzzlers also. Then on, about effluents which generates, you have to recycle it. Last but not least is seawater desalination. Even a lot of industries are coming up in south and west region because desalination plants are becoming more popular day by day. So this is something is very important. Now I'll start with one a beautiful technology. So I'm going to talk about the technical solutions. Clarification, which is a basic fundamental, When water comes to any city, first we do is clarifications. Any industry, if needs water, first is clarification. So when water comes from the river, you need to do the clarification followed by the filtration. These are the basic steps, which are required. So this is the clarification. Till now, government is using conventional clarificators, conventional clarifiers, even today. You will be surprised, even after 70 years or 75 years of independence, still most of the government tenders are with the conventional technologies only, with the older business models, So we brought a lot of good technologies, which of course has been accepted well by public sector units, maybe NTPC, EIL, MECON, SAIL, IOCs and all. So because they are the engineering giants in the world. So they value the technology and they accept it. Plus, of course, the private sector. And then these are some of the different kind of clarifiers which we have introduced to the country over a period of years, So one is very popular high rate solid gate contact clarifier, which is called it as HRSCC. Then we introduced lamellar clarifier, and then now latest ultra high rate clarifier, which is the most compact clarifier in the world. This is HRSCC clarifier. You will never find in any of the municipal, but you will find all best top industries using this kind of clarifiers. Very compact. I do not have much time, so I'll not go into detail. So idea is not to give a technical training program. Idea is to tell you about what is available, what is not available technically, and how it is going to benefit urban and industry world, So this is a photograph of a lamellar clarifier, which introduced about 25 years back. So this is a photograph of Calcutta Bachpat Thama Power Station. It's a massive 72 MLD. This is a clarifier, very compact clarifier for a Maruti Suzuki plant at Gurgaon, There was no space. In spite of that, so much of constraint, we have put up 6 MLD, 6,000 BTU per day capacity clarifiers in a very confined space. So I'm going to talk, which is world's most compact clarifier called ultra high rate clarifier. So this is a combination of HRSCC and lamella. So wherein water comes inside the draft tube, which is there in the center. Then we add coagulants, polymers. I hope you know that to filtration or to carry out the settling of the particles, you add alum, you add PAC kind of chemicals to make sure particles settle down. So all these chemicals are added inside the flash mix draft tube. And then, water circulates in the coagulation zone followed by flocculation zone. And on the top, you see the plates are inclined. So this is a blend of two technologies, hybrid technologies, which is a very compact. So for example, if a 60 MLD plant for a city, if you need to build up a clarifier, so generally conventional clarifiers of the dia 54 meter is a thumb rule, almost 52 to 54 meter is a diameter. Beyond that, you cannot make a big clarifier, right? So 52 or 54 meter is a diameter, right? But when we put up this system, we need only 25 meters, half of the space. So this is something, a very beautiful solution, which we have derived, and a lot of clarifiers are now in India coming up with this technology. This is a 180 MLD plant, so compact, in a steel plant, right? Had it been the case that 180 MLD, 180,000 BTU per day, had it been the case if I had gone for the conventional, so steel plant would have become small and water clarifier would have become very big, So almost more than double of the space, So it helps in making the time very short in building up the systems. Time saving is there. Then these are more smart, more robust systems and more beautiful systems. These are the filtration systems. I'm going to share a very beautiful example of a clarifier, because one of the urban challenges which we are facing is growing population. But where is the land? You have to build up the water treatment plants. You don't have a land. Even if the land is available, place like Delhi, it's so expensive. One of the most expensive cities in the world, right? When you can't buy land, even if you want to buy a flat, it's not less than 4-5 crores rupees. So how you can buy a huge, massive acres of land to build the water treatment plant? So what I did is, the existing clarifier, I have doubled the capacity. So it was almost like 12.5 MGD clarifier of Delhi Jal Board. The same clarifier I have converted into almost 22 MGD. So they are totally surprised. Absolute, it's one of the fantastic thing, a new example I have created, that you need not have to build up the new plant. I can convert your existing clarifier also into double capacity. So this is one of the Asia's biggest plant with 900 MLD. So I told the Delhi board I can make it 1500 MGD. So this is something, they liked it. So this is a photograph of the clarifier. I hope you have seen clarifiers. So this is the photograph of the clarifier. This is a conventional clarifier, right? This is a conventional clarifier. Now this clarifier I have converted into this clarifier. So within this, and this is double of the capacity. So within this clarifier, I have put up another clarifier, which is so compact, so beautiful. So outside ring is the old one. Inside is a new modification, which we did it, and we doubled the capacity. So this is the way we are giving a lot of smart, beautiful solutions to the cities. All big metros are facing these challenges. You talk of all top metros, right? Where is the land available? Similarly, a lot of industries, when they buy land to put up the industries, they're always very short of land. So they want very compact, smart systems. Moreover, these clarifiers are much more efficient than the conventional clarifiers. My clarifier can withstand 5,000 turbidity, and the conventional cannot stand more than 2,000, 2,500 turbidity level. So in rainy seasons, it works as efficient as any top clarifiers in the world. So I've got very beautiful, I just want to show a photograph. This is a clarifier. It's a compact clarifier which we created for rural. Because we are the engineering joint, so my CMD said, why not we look and give some smart solutions to the rural people also. You put it across the river, you add flooded water also into it, you will get the drinking water outlet from this. See, this is a clarifier, ready to build clarifiers. So these are very smart. This photograph I already shown, this is for industry. Wherever any space constraints are there, we can put up. This is a 6,000 metric cube per day capacity clarifier. And I know whether you people, because I know whether you're from industries or not, there is a terminology called DM plants, demineralized water treatment plants, right? So this is a compact skid mounting DM plant, which you probably may not have seen in your life. So this is something, a smart solution, which we have made. Otherwise, conventional DM plants are very big in size. And these are fully automatic, fully managed DM plants, which is used for boilers and high-end water treatment applications, So I'll not cover much into it. My next topic, second topic, is EDB recycling or wastewater recycling. So I'm going to talk again about, earlier when the water comes to the industry, the effluents used to come. One needs to meet the discharge norms of the effluent, and every industry used to have a different norms, because there are 23 different kind of industries. So every industry, Pollution Control Board, CPCB has given a guidelines that what kind of parameters you are supposed to meet, and then you discharge. But gone are those days. These are the history now, right? Now, most of the industries have been asked, you cannot throw out even a drop of water from your complex. So there are 10 top industries which are more polluting industries like distilleries, paper, sugar, textiles, chemicals, refineries, petrochemicals. These have been asked to come absolute zero liquid discharge. You take the water, but you can't discharge it. So these are some of the case studies I like to show, and these are not the new case studies. When effluent, which is in wastewater chemistry, sewage comes at the bottom. Effluents then starts coming up. So effluents are the most toughest things to handle because in industries, effluent characteristics varies also dramatically in a daytime also with fluctuations in the production loads, So this is one of the first plant in the North India. This is a joint venture of IOC and Marubeni, Japan, where they are making rubber. So this rubber is used for making tires. Otherwise, we used to have a natural, this is the first plant in India, which is making rubber, synthetic rubber for manufacturing of tires, So this has got a lot of complex chemical constituents, very toxic constituents, and wherein, effluent is also come at high. So these are the photos of the plant. It is surrounded by only fields. It's a very compact plant in Panipat. And this is something, the actual photographs of the plant. So we are doing zero liquid discharge over there. This is another CTP plant where the BODs are around 4,000, CODs are 9,000, just imagine. So this is one of the plant. I'll show you the photograph. This is a complete scheme. So this is one of the photographs of the plant wherein from liquid waste, I'm converting into fuel also. I'm generating the biogas, and from biogas, I'm running the boiler. So can you imagine waste to energy and liquid waste to energy? So this is one of the most beautiful plant wherein not only I'm recycling 95% of the water, I'm generating power also out of that. So these are some of the beautiful examples. This is another example of power plant, 1400 megawatt power plant. We are using city sewage to feed RO, and then RO is water is used for the boiler applications, 0.1 conductivity. 0.1 conductivity. So these are some of the live examples which we are doing it at many places. Now, at last, since I would like with 1 minute only, so we are coming up with some advanced membranes also, which now the time is constrained, so I will not take up in a very big way. And wherein we'll like to reduce the size of the multiple effect evaporator, which is an expensive affair in the ZLD process. And last but not least is the digital, which I talk, artificial intelligence, how we can check your plants. We have 3 kind of software packages: Insight, Connect, Assure, and Optimize. We can run your system, we can operate your system by sitting at your head office or at my office also, and can solve or mitigate all the problems while running the plants, or whatever the technical problems, flaws comes, or quality issues come, or quantity issues comes. So these can be run in a very smart way nowadays. So all these things are feasible. So we are working, and these are now gaining popularity for all urban sector as well as the industrial segment. So this is what is in 15 minutes. I thought, let me share that. This is some kind of data which you can get on your mobile, This is the industrial. What? ultrafiltration, how it's functioning, how much water you're getting, treated water outlet, what is the pressure, each and every data you can get on it so that you can diagnose the problem, you pinpoint the problem, and you can operate it in a very important fact, in a very systematic manner. So this is all about this. Thank you very much.